Good morning, student for grade 8. Miss Isra with you. Today, we will complete the second lesson, graduation of the elements properties in the modern periodic table. In this lesson, we study the graduation of element properties. What happened to the element property in the modern periodic table? We talk about two properties. First one is about the atomic size. The second property we talk about the electronegativity. And the third property that we will talk about today is about metallic and non-metallic properties. As we study the atomic size, as we move from the left to the right side of the table, as we move, the atomic size decreases. But in the group from up to down, the atomic size increases. The electronegativity also from the left to right side, it's increase, and from up to down, it decreases. Today we'll talk about the metallic and non-metallic properties. As we see, the table divided to four type of element according to the electronic structure and the outermost electron and its physical property. As we see, the blue color, the yellow color, as we see, is all metal. So the four type are metal, metalloids, non-metal, and inert gas. We see this yellow color, the faint yellow color is metal. The dark yellow color is metalloid. The part that has violet color is non-metal, and also the hydrogen here is non-metal. So it has the same color of the non-metal. The maximum right side of the table, this group only called inert gas. According to properties, we see the physical properties and the chemical properties. The metal, we study that the metal has luster, has less than 4 electron outermost, can be malleable, shaping. All of them are solid, except mercury. But the non-metal doesn't have luster, doesn't shine, can't be malleable, it's can be broken easily. Or non-metal are solid or liquid or gases. So they have different properties. And also non-metal doesn't share in any chemical reaction. So this is the group different from all metal or non-metal. But the metalloid, this is between metal and non-metal. It's called metalloid or semi-metal. And we will talk about it today. So the table has four type of element and graduated from metal to the inert gas. As we see, the left side is metal, then after it metalloid, then after it non-metal. So the last type is not noble gases. What happened to the metallic property in the table? Who is the strongest metal? Who is the strongest non-metal? How it graduated in the table? We will make a revision on the atomic side and will complete to the metallic properties. In the same period, what happened to the metallic properties? In the same period, from left to right, from the left to right, what happened to the atomic number? Atomic number increased. In the same period, from left to the right, the atomic number from the left to the right, the atomic number, what happened to the atomic number? The atomic number increased. So atomic number one, atomic number number one in the properties. Atomic number increases in the same period. As we move, the atomic number increase. We see lithium has 3 atomic numbers, then beryllium 4, and so on. So the atomic number increase. What happened to the size? We see the size decrease as we move from left to right. So the atomic size decreases. This is what happened to the atomic size in period. We talk about period. Okay. So the atomic number increase, the atomic size decrease in period. What happens to the electronegativity? It's opposite to the atomic size, as we see. When the atomic size decrease, the nucleus attracted the outermost electron more, so it can't let it go freely. So the atomic electronegativity increase. When the atomic size decrease, the nucleus attracted the outermost electron more, so the electronegativity increases. This is what happened to atomic number and size and electronegativity in the period. But we talk about the metallic properties and non-metallic properties. The metallic properties increase. Metallic properties related to the number of electron outermost. As we see lithium here in the first group, it has atomic number 3. So has 2 electron in K and 1 electron in L. So it has 1 electron in K, 2 electron in L, 2 electron in K, 1 electron in L. So it has 1 electron in outermost, and sodium 11. So it has 2 in K, 8 in L, and 1 in the outermost. So all the group 1A has 1 electron in the outermost. When it has 1 electron outermost, it can let it lost easily. It has 1 electron outermost, so it can lift it and it can lose it easily. Then it has 2 or 3 or 4 in outermost. So the strongest metal that has 1 electron outermost let it lost easily is group 1. So the strongest metal, we start from the left side, the strongest metal. As we move from left to right, the metallic property decreases because the number of electron outermost increase, and it's not easily to lose. It lose electron. Yeah, all the metal lose the electron, but it has 2 or 3 or 4 electron in the outermost, not easily to lose than if it has 1 electron. So the metallic property decreases as we go from left to right. So the metallic property decreases. As we see in period, the atomic number from left to right increase, atomic size decrease, electronegativity also increase, and the metallic property decrease. This is what happened to the bond. The metallic property opposite to non-metallic property. Metallic property opposite to non-metallic. So when the metallic decrease, the non-metallic increase. So number 5, the non-metallic property increases. This is what happened to, this is all about properties of the element that we study in this lesson. Period, atomic number increase, atomic size decrease, electronegativity increases, metallic decrease, so the non-metallic increase because they are opposite to each other. But what about in group, in the same group from up to down, the atomic size increase because the atomic size increase in period and group, because this is a graduation of the modern periodic table. So the atomic number increases in each case. The size, what happened to the size? Size, it opposite to the period, so it increases. Increases. The atomic size as we move from up to down increases as we study in this lesson. Number 3, electronegativity. It's as the size increase, we see that the attraction between the nucleus and the outermost decrease, so electronegativity decreases. The nucleus not attracted to the outermost, when the size decrease, so the electronegativity decrease. As the size increase, attraction force between nucleus and and the electron outermost decrease, so electronegativity also decrease. What about metallic property that we study today? Metallic property, as we move down, it increases. It increases. Metallic property increase. As we move down, the metallic property increase. And non-metallic opposite to it, so non-metallic decreases. This what happened to the properties in the group. In the same group, from up to down, the atomic number increase, atomic size increase also, the electronegativity decrease because the attraction force between nucleus and electron decrease. The metallic property increase as we move up. The strongest metal lie in the bottom element of the group. Non-metallic property opposite to metallic, so it decreases. This is what happened to the property in this lesson: atomic size, atomic number, electronegativity, metallic and non-metallic property. So the strongest metal lie in group 1A because the metallic property as we move left to right decrease, so the strongest metal in group 1A. As the metallic property move down increase, so the strongest metal is cesium because it's the bottom of group 1A. This is what happens. The strongest non-metal as the non-metallic property increase as we move in period. So group 7A, and group 7A has the strongest non-metal. So the group 7A strongest non-metal, but group 1A strongest metal. The cesium in the bottom of the left side of the table has strongest metal in group 1A, and the fluorine strongest non-metal as metallic and non-metallic products. Cesium strongest metal in group 1A, fluorine strongest non-metal in group 7A. 1A has the strongest metal group, strongest non-metal is 7A or 17 in the modern number. This is what happened to the metallic and non-metallic properties. As we see, The non-metallic. The strongest non-metal group is group 7A or 7C. The strongest metal in group 1A in the beginning of each period. Inert gas is the chain group or zero group as we studied. This has four properties. So in the table we study have four properties: metal, non-metal, metalloid, and noble gas. What is the, we see the metal is the element that has less than 4 electrons outermost. Non-metal, the violet color, is the group has more than 4 electrons outermost. Noble gas doesn't share any chemical reaction because the outermost completely filled with 8 electrons. But this group that has yellow color is six number of element called metalloid or semi-metal element. This is has properties of both metal and non-metal. This is has the most property of metal, but has some property of non-metal. This is element has six only. Number one, boron, silicon, germanium, arsenic, antimony, and tellurium. Boron, silicon, arsenic, germanium, antimony, or tellurium. This is a six element called metalloid. Because it has both properties between metal and non-metal. It's mean it has shiny and luster like metal, but some of them doesn't lose electron like metal. It can gain electron or lose the both. It can lose and gain electron. So it has properties between metal and non-metal. It has some property of metal and some property of non-metal. So we call it metalloid between metal and non-metal. We will talk about the chemical properties of metal and non-metal and how it reacts. Chemical properties mean how it reacts in reaction. We will talk about metal. First, metal reacts with dilute acid and reacts with oxygen. We have experiment with between acid and metal. We study the acid. It has start with H, and when dissolved in water, forming positive hydrogen ion. This is the acid. So any acid start with H, hydrogen element, and when dissolved in water, it's formed positive hydrogen ion. Dilute acid meaning acid not concentrated. Dilute meaning it's added to it water. It's diluted with water, so not concentrated. When the metal like magnesium, we bring the test tube and putting in it magnesium bar or piece of magnesium metal, like iron but soft, and putting there HCl, hydrochloric acid. HCl, we called it hydrochloric acid because hydrogen and the chlorides are called dilute hydrochloric acid. When we adding magnesium to dilute hydrochloric acid, we see bubble evolved, and this bubble is gas. So gas bubble evolves and get out from the test tube. This is, and after testing it, it's hydrogen gas. So when any metal act with dilute acid, hydrogen gas evolved and get out from this reaction. And we write the chemical equation like that: magnesium Mg, hydrochloric acid HCl to HCl. In the arrow, we write the dilute because the acid is diluted. It's added to it water, not concentrated. What is the product? Product is salt of acid. Salt of acid meaning acid. We study that the salt it's action between positive ion and negative ion. Any salt composed from positive ion, magnesium is a positive ion, and the chlorine is negative ion. This is a salt. So when any metal reacts with acid, diluted acid, the formula is salt of the acid. So it has symbol of the acid chlorine and added to it magnesium. So it's called magnesium chloride. This is salt of the acid. Salt between positive and negative from the acid and evolved hydrogen gas. This is called reaction between metal and diluted acid. So the metal react with hydrochloric acid, forming salt of acid, but diluted acid, and evolved hydrogen gas. Metal also react with oxygen. When we bring test tube and hold magnesium strip or magnesium pieces with holder, with metal holder يعني, putting in a test tube and burning it. What is happen? Magnesium react with the oxygen, and we see white powder formed in the bottom of the test tube. White powder formed here in the test tube because magnesium react with oxygen, formed new matter called magnesium oxide. Because the magnesium react with oxygen to form it between them, so it's magnesium oxide. White powder formed in the bottom of the test tube. The magnesium oxide called oxide, and we study there are two types of oxide. When an oxygen react with metal, it's called metallic oxide. Metallic oxide. So the magnesium is metal react with oxygen, form magnesium oxide called the metallic oxide. And when we put in water, dissolve the white powder of magnesium oxide in water, it formed base. Base meaning basic. Base means when any compound dissolved in water formed hydroxide ion, positive ion in the reaction, called base. So the base any element, sorry, any compound that when dissolved in water forming hydroxide ion. So when the magnesium reacts with oxygen, forming magnesium oxide, this is a basic oxide or metallic oxide. It's metallic oxide. When we adding water to the magnesium oxide, dissolve the magnesium oxide in water, formed magnesium hydroxide. Meaning which element, meaning its base. When the element start with H, this is acid. When it has positive and negative ion, the element composed of two elements, positive and negative, is called salt. The difference between acid and salt and base. So when the metal reacts with oxygen, it formed metal oxide. In this case, magnesium oxide white powder. When we add water to the magnesium oxide, dissolve in water, forming basic oxide because it has OH group. It's magnesium, called magnesium hydroxide. How we know it's base? We can test the base or acid as we study by litmus solution. Litmus solution. We study litmus paper, but it has another example, litmus solution. Litmus solution, its solution, its color change when we add it to the compound. When its color change to blue, it has a violet color. The litmus solution has violet color. When we add to solution and change its color from violet to blue, so the solution has a base. Has a base. So why we see that the oxide that formed is basic oxide? Because when it dissolves in water, change litmus paper, litmus solution from violet to blue. This is how the metal reacts. This is how the metal reacts. So again, the metal has chemical properties, so it reacts. We have two reactions in this lesson about metal. React with dilute acid, like dilute hydrochloric acid, hydrogen gas evolve. All the metal will react with dilute acid, forming hydrogen gas and salt of acid form. When it reacts with oxygen, metal oxide formed. We call it basic oxide because when the white powder of magnesium oxide dissolve in water, forming solution called the basic solution or alkaline solution. Alkaline solution, because when we add in the violet solution, litmus solution to it, change the color to blue. So it's called alkaline solution. This is how the metal reacts. And the beta oxide means metallic. For base, any metal dissolved with active oxygen form basic oxide, because when dissolved in water forming alkaline solution or basic solution. So the beta oxide, the metallic oxide, when dissolved in water forming alkaline solution. This is the definition of basic oxide. As we see, the solution color changes to blue, so it's alkaline solution. Why we said that all bases uh, aren't alkalis. Alkali mean base, but not all base we say it alkali. Why? Because the alkalis are base dissolved in water. Not all bases dissolve in. So the bases which had hydroxide group and the alkali also part of bases. Alkali are part of bases, but dissolve in water. Not all bases dissolve. So the most bases doesn't dissolve in water. Only the alkali elements dissolve in water. So not all bases we see red alkali, because the alkali dissolve in water, and not all bases dissolve in water. So the alkali is part of bases that dissolve in water. This is the reaction of metal with oxygen and the acid. From the reaction with element of metal with with water, sorry, with oxygen and acid, also react with water. React with water. And they arrange the metal according to its activity. Who react with water strongly, who react with water slowly, or don't react with water. So they are arranged some elements: potassium, sodium, calcium, magnesium, zinc, iron, copper, silver. They arrange the elements from potassium to silver as decrease in chemical properties. With the first one, react with water strongly, and as we move down, the activity with water decrease. It's called the chemical activity series. So the chemical activity series is arrangement of metal. It's arrangement of metal, descending order according to degree of their chemical activity. So the chemical activity series, they arrange the metal descending from the strongest metal to react with water to the slowest one, or doesn't one react with water according to chemical activity. Starting from potassium, sodium, calcium, magnesium, zinc, iron, copper, and silver. And we found potassium and sodium react strongly and instantly as soon as we put the water, it has fire explosion happen, because the potassium and sodium very reactive metal. They react with water and hydrogen gas evolve with top sound. So we hear a strong sound happen after reaction of potassium sodium with water. When they are reacted with water, or when it's exposed to the water vapor in the air, they react instantly, and the pop sound happen because the hydrogen gas evolved. This is pop sound from the hydrogen gas evolved, because the hydrogen is very active gas. The calcium and magnesium react not slowly with cold water, like slowly but with cold water. Zinc and iron, they found react with oxygen or water vapor only at high temperature. So the iron and zinc doesn't react with hot water. Sorry, doesn't react at low temperature. So the zinc and iron react with hot water vapor only, but at high temperature. When they are a fire and we putting iron on it, it reacts with water vapor. Copper and silver doesn't react with water because they are inactive metals. Inactive metal. This is the chemical activity theory. It's arrangement of metal descending from the strongest metal to the slowest metal in activity according to the chemical activity. From potassium to sodium react strongly, distantly with water vapor and sound due to hydrogen gas evolving. Calcium and magnesium react slowly, take a long time to react with cold water. Zinc and iron act with high temperature with hot water vapor only. Copper and silver doesn't react with this is about metallic properties. This is all for today. We study what happened to the metallic and non-metallic property. Who the strongest metal, who the strongest non-metal, who the group has strongest metal, the group has strongest non-metal. What happened to chemical activity of the metal with water and there is acid and the oxygen and the chemical activity theory. This is for today. We complete this lesson next session. Thank you.